Landsat ETM, with the bands separated off. So each one comes as a separate TIFF file. And then there's an old multispectral sensor satellite down here as well, that we'll work with as part of the assignment more than anything else. So this is often how satellite imagery comes, because there's different ways of processing things and there's different ways that people like to work with imagery. Usually they'll give you things as individual bands like this, as opposed to one already stacked multispectral image. So our first step when we get everything loaded up is going to be to create that multispectral image out of these individual bands. So let's go ahead and switch over to ArcGIS Pro. I'm going to start my new project as usual. I'm going to put it over. It's going to let me. I'm going to put it over in my usual spot. Just in that new folder that I created within my GIS folder. Put it there, and just telling it not to start a new project. You can if you want to. It's not a huge deal. Oh, I'm going to change the name so that it's actually for imagery. And our next step is going to be to go ahead and add in those 8 individual bands that we had there. So when this loads all on up, there we go. Make sure you have a catalog open. If you don't, you can go to map, add data, get to the same sort of places, or you can go to view, catalog pane or catalog view, and have some way to get in through your catalog here. And we're going to go through folders. It's just in the lab for satellite imagery folder. And I'm just going to highlight these 8 that I want right here, holding down Shift to get them all, and then just drag those over. Might take it a second. Might have even not realized that I was trying to do it. There it is. So I think I'd already at some point said to automatically build pyramids and do statistics. If those messages pop up, you can say yes, you can say no. These are small enough imagery that it's not a huge deal. If you don't do those things, they just render a little bit faster at the expense of things taking a little longer to load at the beginning. Okay, and what we see now that we have is the individual bands all as separate kind of grayscale images here. What we're going to want to do is order those so that we have 1 at the top and 8 at the bottom. You may or may not have hedgers come in properly. It probably depends on how you selected them. Another thing you can do, if it makes it easier, is you can just minimize all of these. You can also right-click up here, and somewhere there's minimize all. Maybe it's in a group or something. And what I want to do is just get it so that it's 1, 2, 3, 4, 5, 6, 7, 8. And now we can kind of start looking at these the same way we did with the different bands of a Landsat in the lecture as well. So if I zoom in just a little bit, you can kind of see that, you know, this is band 1. I turn it off. That's band 2, which is green. And then we get red. See our near infrared starts looking a lot different. We'll get further out into the other wavelengths of infrared on band 5. Get out to the thermal in band 6. You can see a couple things that happen. One, it gets to be a much lower spatial resolution because remember, those thermal sensors are not as precise. When we get to band 7 in the middle infrared, you can see a little bit going on there. It's a little different. Then when we get to band 8, this is that panchromatic band. So if you look at it, you see that it's actually a higher spatial resolution. It's that one that's 15 meters instead of 30, the way the rest of the Landsat imagery is. So just so you're aware as well, if you were to go into the layer properties of any of these, you'd be able to see what the resolution is. I'm just double clicking. It's just in source here. And then sort of in raster information, it says 30 by 30. I just told you that some of these are higher resolution and lower resolution. Band 6 here, I artificially increased it to be 30-meter resolution instead of the 60 that it comes at. That was because in an older version of ArcGIS, if the resolutions weren't the same, you couldn't it would go to lower resolution when you stacked them. So I had artificially done that, so just keep that in mind if it comes across there. And then band 8 will be 15 because it's the higher one. So the next thing we want to do is actually make a panchromatic, nice stacked image out of these. I'm just zooming back out so you can see the whole thing. And we're going to do that in sort of the imagery raster functions part that we worked with a little bit before. So we're going to go to imagery, raster functions. And again, these are things that generally tend to run things temporarily. So it's going to make a temporary output for us, which is actually largely what we want at this point. So we're going to go in through here. I'm going to just reduce my one here. You could go and search for this tool that I get to eventually, but we're going to go to imagery, raster functions, data management, and then there should be a composite bands function right here. And I'm going to add my first 7. I don't want to add band 8 because it's a different resolution and it repeats some of the other information that's in there because it's the same as 2, 3, and 4, I think. So I'm going to drag this over. It's not going to work if I drag it over, but I can add them sort of one by one here as well. That's kind of a bummer that it doesn't let you add them over. So 6, 7, 1, 2, 3, 4, 5, 6, 7. I'm going to change my cell size here. I could do whatever I wanted to on this one. Remember I said before that I had artificially increased to band 6. That's not necessary to do anymore, but I didn't reprocess it because it would be silly to. So you want to choose probably max of is just fine here. You could also choose first of if you wanted. It doesn't really make any huge difference. Okay, so we're going to go ahead and hit create new layer here. It's going to create an output raster layer. And really, really quickly, we now have that 8-band or 7-band image pulled in for us here. So if I go open in here and go to properties, you'll see somewhere in here my raster information. It's a 7-band, regular kind of standard Landsat, all sorts of things there. Remember also, once you've created this sort of composite, that you can change the symbology on it to show different bands. So right now it's 1, 2, 3. Technically, this should actually be 3, 2, 1. You see that looks a little bit more like real stuff. Some of that's the stretch as well, but that's because it's green, blue, or sorry, red, green, blue. We could also do those false color ones where it's 4, 2, 1 or 4, 3, 2. Part of the assignment is to look up some other options of things that you can see with these false color images. So at this point, we could make this whole thing permanent if we wanted to have this Landsat image ready to go. Or we could go ahead and crop out the area that we're interested in. And that's probably the one that we want to do at this point. In fact, it definitely is because it's part of the assignment. So just like we did cropping last time to the extent of your park, this time we're going to do it to the extent of the quad sheets that you used throughout stuff. So I'm going to go just show where to find this stuff. I'm going to go to map, add data. You could do this through your catalog tab also, pretty obviously. I'm going to, in my project, I do not have anything chosen for other things. So I'm going to go to folders. I'm actually going to go in through this way. I'm going to go through this PC drive because I need to get to an older folder that's in there. And I believe we did the quad sheets. I think I gave them to you in vector. So I'm going to go in there. For some reason, I put my assignment data inside of something. And what I'm looking for is Indiana quad index right here. Bringing it in shockingly slowly. I would imagine that this is Google Drive stuff. And now I have my quad index. And if you remember, what I really want to find is the quad sheets that I was interested in. So a couple things that I like to do. Right now, my symbology is still up for this one. If you didn't have that up, you could right click in here and go to symbology. I'm going to change that to be just a black outline so I can see through it. And then I'm also just going to go down here and choose label. And the ones that I know that I want for Notre Dame are South Bend West and South Bend East. So I'm going to go on my map to my select tool here, and I'm just going to select those two. Okay, so that's where you want to be. You want to have created a composite bands. You want to have a quad index ready to go. And what we're going to do is now go to the raster clip function that we worked with before. So we go to Analysis, Tools, and we can just search in here for clip raster if we want. There's other ways to do this, but this is the one that is the kind of most quick and efficient one. I'm going to go ahead and bring over my input raster, oops, as composite bands. My output extent is quad index. Once it realizes what I have it pointed at, it's going to ask me about the selected features and things like that. So use selected features. In this case, I want to use input features for clipping geometry. And I want to save this permanently. So I'm going to put this, I could put it in my database here if I wanted to. But remember, that's going to be just slightly harder to get to in future ones. So I'm going to put it into the folders, lab 4 right here. And I'm going to call it Landsat ETM 2000 Notre Dame .tiff. And your no data value, you can leave it as 256. You can leave it, you can make it 0 as it says in the notes. It doesn't really make a huge difference. It's just what the color is for any no data that's in there. Okay, and go ahead and hit run. So it's done it, and we now have just that area. It's reset the band combinations to be 1, 2, 3 instead of 4, 2, 1. We could fix that if we wanted to. But then the last thing we want to do is we also want to do that just for band 8. Now, normally you would have to do, you could do this all over again. In this case, you could just come here in the dropdown and just switch this over to band 8. It's going to give you the same input stuff. That's what you want. I'm going to go ahead and put this as just, probably should have said the other one was multispectral, as pan right there. So ETM 2000 pan. Hit run. So now I've got both. I've got a cut down version of the panchromatic and a cut down version of the multispectral. At this point, I'm basically done with all of these 7 bands here. And I'm probably done with the composite one also. I would say if you're following along with your own stuff, go ahead and save those because you need them for the assignment. But you can just turn them off so you don't have to see them anymore. Same with the quad index. You're not going to need that again. Because really what we're going to work with now is just that cut down part of either 2 or 4 sheets that you're going to work with for the rest of the demo. And I would say if you're following along with your assignment, go ahead and use the ones that are already, like, just use yours instead of the Notre Dame ones. Okay, so the next thing we want to do is that pan sharpening tool, where we're going to go through and take the resolution from the high resolution panchromatic and sharpen the multispectral one. So we're going to go in to, again, imagery, raster functions. We're back in here. This one is in appearance. And they put it in appearance because this is not something you usually do qualitative. Like you don't often use these things in like a really quantitative way. You pan sharpen so that you have an image that just looks a little bit prettier. So you're going to bring in it asks for a multispectral and a panchromatic. So your multispectral is going to be, I didn't give mine a good name, and your panchromatic is here. Pan sharpening type, I would just leave it at S3. These are the default, how much it weights each one of them. In this case, we're not going to change them, but every satellite that has a high resolution panchromatic band has the metrics released somewhere. So you could change these if you needed to. And we're going to go ahead and hit create new layer. Now, it doesn't necessarily look like much changed, but when you start to zoom in on it, what you see, if you turn off the one, and we're just looking between the two, you can see that it's taken the resolution from one and applied it to the other. And if we were to look at changing the band combinations here, so I'm just going to go to my symbology, and I'm going to go, so you see you only have 4 bands now, and that's because that panchromatic band in Landsat only covers the first 4. I think I maybe said 3 earlier, but that covers the first 4. So if I wanted to see the false color, I could do that. Not 100% accurate. Again, in 2000, Notre Dame Stadium still had real turf instead of AstroTurf. Always kind of cool to see. Okay, so pan sharpening, get it done there. That's how you do it. And now you have something that can visually be a little bit more striking, but isn't necessarily any more quantitatively useful. Another thing we can do is those vegetation indices that I talked about. And we're going to do, in this case, the NDVI, which is probably the industry standard, the most commonly used one here. Again, we do this on the multispectral image because we need that ratio between near infrared and red. And we're going to do it again in imagery, raster functions. In this case, it is in analysis. And we're going to do NDVI regular here. NDVI colorized can give you some differences, but it's really just, it's not doing anything different. It's just what the output is. Okay, and we're going to give it our Landsat panchromatic or multispectral here. Here, this is an ETM imagery. So I'm just going to tell you that the visible, like infrared band, so the visible band ID is going to be 2 or 3, sorry. And the infrared band is going to be 4. I want you to just know offhand that when you're doing part of the assignment, it asks you to do it on the old multispectral satellites, multispectral sensor satellite, and that should be 2 and 4. If you're doing it on Aster, it's 2 and 3. This is just something you have to know, is this is visible red, this is infrared, because it's the ratio between those two things. You can choose scientific output. That'll make it from -1 to 1. I kind of like that better than 0 to 200, the way that Esri likes to do it, but it's up to you. I don't have a strong preference about which one you do. I just prefer the 0 to 1, or sorry, the -1 to 1. So I'm going to create my new layer. And again, so it's scaled it from 0 to 1 to 200. I'm going to go ahead and take my Landsat over here. Sorry, I'm going to switch my symbology over here so that it's showing me the same thing. So I'm going to show 4, 2, 1. And what you see is the NDVI. So things that are white are higher NDVI values. Things that are black are lower. So river, lakes, no vegetation really in them. Fields are going to be relatively high. Forests are going to be relatively high. And you can see the same thing on the near infrared. But some of the differences that you start to see are that there are places that are just high in the near infrared that are not actually all that vegetated. So like this area in here is high in the near infrared because you can see some of the soil through it more than anything else. It's just a field. The golf courses don't pop nearly as much on NDVI because there's not a huge difference between the greens and the fairways, but there is in sort of the color of them, so they still look really, really different on the false color image, but they don't pop as much in the NDVI. So it's a much more quantitative way to look at it, although it's less visually striking, certainly. Okay, so the last tool that we're going to do, knowing that there are some other ones of these out there, is that principal components analysis. And if we're going to do principal components analysis, we're going to do that on our original Landsat here. And the PCA is again in, we're going to go to the analysis. We're going to go through tools. This one's just in the toolbox. So make sure you have toolboxes up here, not favorites or suggestions. You can also just search for principal components here. It'll come up. But if you want to go through the actual toolbox itself, it's in, it's just search for it. It's just easier to search for it. So principal components, PCA is what we're going to run. Our input raster bands, we could define individual ones, but I'm going to give it the ETM. Output multispectral raster here is going to be, call it whatever you want. I would just say, I would give it a name. This one you probably will not use again, so it's fine to leave it in the geodatabase if you want. You can also save it as permanent if you need to find it more easily again. I'm going to call it Landsat PCA. We're going to leave the number of principal components as 7. And I do want to output a data file. This is going to let us look at those eigenvalues and things like that. That'll give us some idea of what's happening there. I'm going to call it Landsat PCA eigen.txt. And I'm going to hit run. And it's going to fail on me. Okay. So sometimes this happens where the tool that it's running behind the scenes really hates to have spaces in anything. And it's probably around this data, this output one right here. So I'm going to just go, and I would encourage you to probably do the same thing when you're on. It's because my drive has a space in it, and there's absolutely nothing we can do about that. So you might need to do this on your computer as well, where you just stick it in like downloads or documents or something like that. Something that doesn't end up having a space in it. So hopefully it'll finish that time. Yep. Yeah, it's the same problem. This problem has been around for like, this was in desktop as well. So clearly when they made Pro, they didn't fix the same problem. So it may take it a second or two to run just because it's doing this like 7-dimensional space thing and figuring out where everything should be and that kind of stuff. But the idea at the end of it is when we're finished with everything that's running here, it's going to come in with an image that's each band in the image is one of those principal components. So the first one explains the majority of the variability, the second one, the next amount, the next amount, the next amount. And we want to be able to assess from those eigenvalues how much variability in the entire variabilityness of the image is being explained by each one of the components. So when the principal components is ready, what we'll see is that probably the first couple are useful. They probably explain 70, 80%, if not more, of the variability in the image. And then eventually we get out to things that are a little bit more noisy. I talked about this a little bit in the lecture, but it's an important analysis technique for removing noise sometimes. It's what we do to kind of figure out certain things that are in there. And there are these kind of what we call post hoc analyses, so after the fact analyses that can tell you quantitatively what is probably driving particular components in there. Although we can kind of guess at it usually just from looking at the image and sort of figuring out, oh, that one's the distinction between water, not water. That one's the distinction between like different types of forests and that sort of thing. So as soon as this thing is done, now that I've re-given a lecture about principal components, the other thing that it always likes to do, which is really silly, is it brings it in as if it's a false color image here, an RGB image, and it's not. So that's why it looks like, I don't know, the Hulk from space or something like that. So if we go through, into symbology, our primary symbology shouldn't be RGB, it should be stretch. And then what we're going to do is sort of investigate each one of those bands as it comes through. So band 1 here is going to be the first principal component. I'm not positive if it brought in my table that I need, but we'll see. So I'm going to come over here. ArcGIS is being very slow while I'm trying to demo. There we go. So that first principal component, you can sort of see what's going on with it a little bit. Looks like it might be kind of a distinction between like urban areas and not urban areas. When we start getting to 2, just going to turn off some of these things in the background in case that's what's slowing everything down, which it's probably not. Looks like it might be water, not water is probably the biggest driver there. You can see that the water is still really dark and everything else is kind of really light, and maybe something else is happening in there also. Start getting even further down into 3. And eventually we'll get to things where you can't really see any distinction in it because it's probably not explaining very much of the variability. And in fact, if I can get it, I'll show the eigenvalue file that has that information in it. There we go. Now we're starting to see things that are maybe not quite as useful. So I might have it in here. It just depends on whether it's loaded it in or not. So what I did up here is I switched to data source instead of drawing order. And often what that'll do is let me see places like things that don't have a spatial component to them, like tables. But it looks like the new version here doesn't actually bring that in. So I'm just going to go back over and open it somewhere else. So I'm just opening that file that I pushed into my downloads, I hope. Yep. And what it brings in is a text file that you'll need to open somewhere else on your computer. And that text file looks like this. You could open this in ArcGIS too. It'll open, okay. And the important thing is actually down at the bottom here, where it's saying, hey, that first principal component, based off its eigenvalues, explains 76% of the variability, then 15, 5. When we start getting down to these lower ones, it's less than 1%. So there's really not a lot of variability being explained, even by this third one that I have pulled up here. It's only about 5%. And then when I get down to like 7, if it'll render, you'll see that there's just not a lot in there. Okay, so that's about it for working with the raster data that we're going to do, or the satellite imagery data that we're going to do so far within the demo. Feel free to reach out if you have any questions or anything. Otherwise, good luck, and we'll keep working on.